Alright. Learning event 3. Describe the purpose of operation electric automotive accessories. Your instrument panel, usually placing the instrument may be readily easy to move the driver. The information the drive informs the driver approximately speed, engine temperature, oil pressure, rate of charge, discharge of the battery, amount of fuel in the fuel tank, distance traveled, and the time. Certain control frequencies are mounted with the instrument board, such as throttle, choke, starter, heater, and windshield wiper. Battery conditions gauge. One of the instruments always placed and included with the instrument panel. Battery condition gauge is very important to indicate with the interpreted properly with the troubleshooting and prevent breakdowns. Following are 3 configurations of the battery condition gauge. Ammeter indicates the amount of the current flowing from the battery, and it does indicate the total generating output that because the other units of the electrical system beside the battery are supplied by the generator. If it shows 10 ampere discharge, it indicates that 100 ampere hour battery will be discharged in 10 hours. If there is 10 amperes flowing for 10 hours, current flowing from the storage battery starting motor is never sent through the ammeter because of the greater quantity of the 200-600 amperes cannot be measured with any on an instrument, so it's limited capacity. A typical ammeter current flowing from the to and from the battery, except for the starting actually is sent through the coil, producing a magnetic effect that deflects the ammeter needle portion to the amount of current. The coil is matched to the maximum current of the output of the generator. To verify the different applications, some model wheel vehicles have replaced the ammeter with the battery generator, indicate with the soul that does the give of the calibrated reading of but shows the range of the colors or bands. Voltmeter. Voltmeters gain popularity with the instrument panel, generator, and battery condition indicator. This is back up with the electrical system. Voltmeter accurately indication of the condition of the electrical system. Amperage is easily interpreted by the operator during the vehicle operation. The voltage indicated voltmeter considered to be normal range of 13.2 to 14.5 volts for a 12-volt electrical system. As long as the system voltage remains in the range of the operator can assume that no problem exists. The contract of volt. Well, this contrasts the ammeter because which the operator now indicates the problem, such as the improperly calibrated voltage regulator, which could allow the battery to be drained and regulation system voltage to the level that is below normal. The indicator lamp. Overview for the indicator lamp has gained popularity with electrical system condition gauge, although it does not provide the detailed analysis for the gauge, but is usually considered one or more useful of the average vehicle operator because of the high visible with the malfunction occur, whereas gauge is usually ignored because of the average vehicle operator does not know how to interpret it. Reading the indicator lamp can be used in 2 different ways to indicate the electrical system malfunction. Low voltage warning indicator. The indicator can be set for the warn operator whenever the electrical system voltage has dropped below the normal operation range lane, or as operated with the calibrated relay open to the circuit whenever the electrical system voltage is normal range from 13.2 to 14.5 volts at the 12-volt system. Whenever the voltage falls below the normal range, the magnetic field picks up becomes insufficient to overcome the force of the relay spring, which pulls the contact points closed. This closes the circuit of the indicator lamp. The no-charge indicator lamp. The indicator lamp show that can also be set to indicate whenever the alternator is not producing current. Circuit that operates with no-charge indicator lamp usually incorporated with the voltage regulator. This is used with the vehicle equipped with the no-charge indicator lamp. Contains a second element called the field relay. Field relay has 2 contact points, one connected with the battery voltage through the ignition switch. The other one is connected with the same way, except for the conclusion series parallel arrangement of no-charge indicator light or the resistor values matched with the resistance of the indicator lamp, so the parallel arrangement will produce a 0-volt drop of the field relay is open the alternating field current and supply through the resistant indicator light. Combustion of the magnetic coil of the field relay is energized directly from the alternator state with the stator terminal where the ignition switch is closed before the engine starts. The current flows through the resistor indicator lamp to the alternator field, causing the indicator lamp to light after the engine started. The alternator being to produce the current with the energizing field relay from the stator relay coil pulls to the relay points closed with the shedding alternator field directly with the battery. The result of 0 potential across the indicator lamp and causing it to go out. Alright, your fuel gauges. Most fuel gauges operated electrically and composed of the 2 units of the gauge mounted on the instrument panel. The sending unit mounted on the fuel tank with ignition switches included with the fuel gauge circle. The electrical fuel gauge operates only with ignition switch. If the open electrical gauge depends on either cool action of the thermostatic action. Thermostatic fuel gauge, self-regulating. This gauge configuration consists of the instrument panel gauge, the electromagnetic sending unit that is located inside the fuel tank. The instrument panel gauge contains electrical heat of the biometallic strips that is linked to a pointer. The biometallic strips consist of 2 similar metals that when heated expand at different rates, causing it to deflect and bend. It may cause the instrument panel fuel gauge the deflection by metallic strip will result in movement of the pointer, causing the gauge to give the reading. The sending unit consists of a hinge arm with a float on the end of it. The movement of the arm consists of control of the ground point with the contacts within. Another point is attached to electrically heated biometallic strip. The heating coil and the tank of the unit gauges connected to each other in the series. Alright, operation. When the fuel tank is empty, the float lays to the bottom in position of the arm, operated with the cam, the surf, the no pressure for the ground contact with the ignition switch. If the current flows through the ground, through the heating coil with the sending unit, with the heating coil with the instrument, with the panel gauge, with the battery, with the heating of the bimetallic strip, is the sending unit causes it to deflect. Opening of the contact points. The opening of the points will allow the bimetallic strip to cool, return to original position. Again, the closing of the points of the cycle. Opening of the closing of the points will continue supplying current pulse heating element in the fuel gauge. Length of the pulse of the sending of the unit with the tank is empty, with the only heat with the gauge of the bimetal only heat by the gauge by metallic strip enough to cause deflection that will move the pointer to the empty position on the gauge face. When the fuel tank contains fuel, the float will raise the arm and causing the cam to push the ground contact tighter against the bimetallic strip contact. This will cause the increase of the amount of the heat required to open the contact points in the sending unit. The result will be a longer current pulse of the instrument panel gauge, causing higher gauge readings. The gauge will read and increase proportionally with the float level in the fuel tank. The tank unit will compensate with the variation electrical system voltage automatically. High voltage will increase the heating of the causing the points of the cycle faster. Low voltage will decrease the heating causing the slower point cycling. Because the gauge pointer is moved by heating and the cooling of the bimetallic strip, the gauge reading will not react to sudden fuel level changes caused by fuel sloshing. This prevents erratic operation. Alright, your thermostatic fuel gauge, external regulated. External regulated thermostatic fuel gauge use the instrument panel gauge whose operation is the same as the gauge due to the self-regulating system. The difference in the system due to the variable resistance fuel tank sending unit and the external voltage and top limiting device. Sending units control the gauge through the use of the rheostat. Rheostat is wire wound resistance whose values varies with the effective length. The effective length of the rheostat is controlled with the sending unit. Sliding brush is operated by the float arm. The power supply to the gauge is kept at constant for the use of the voltage limiter. Voltage limiter consists of a set of contact points that are controlled by electrical heated bimetallic arms. Or when the fuel tank is empty, the float lays on the bottom of the float arm will position the contact brush for the full length of the rheostat. Resistor will utilize the resulting high resistance with a drop of the voltage gauge sufficient to the pointer rise only to empty. As the fuel level rises to the tank of the float will raise the float arm, which in turn will move the contact brush for the rheostat. Resistor of the float arm moves upward. The resistance will decrease the proportional result of the proportional voltage increase to the gauge. The gauge reading is an increase of the proportional result of the accurate reading of the fuel level in the tank. The voltage limiter effectively ensures the constant supply of the current regulated to the equivalent of 5 volts to produce the accurate gauge reading regardless of the electrical system voltage variations. Or your thermostatic fuel gauge differential type. The differential type of the fuel gauge system uses the instrument panel gauge whose operating principles are much the same as the thermostatic gauge. Different type of the thermostatic gauge, however, uses the two electrical heated bimetallic strips that share equally operating supporting the gauge of the pointer. The pointer position is obtained dividing equal available voltage between the two strips. Differential. The tank unit of the rheostat type of the operating principles are as much as the tank unit described in the paragraph above. The thermostatic fuel gauge externally regulated. The tank unit is used in this system because this contains wire wound resistor connected between the two external terminals. Each one of the external terminals contact one of the instrument panel with a gauge with a bimetallic strip. The float arm moves the ground brush with a high raised resistance progressively, one terminal with lower resistance to the other. This causes the voltage division, resulting heat differential of the gauge strip. The formulate gauge reading two additional bimetallic strips are provided with a temperature compensation. In addition, one of these blades operate with the contact points limit the value voltage to approximately 5 volts. Alright, operation. When the fuel tank is full, half full of the float arm position with the contact brush midway of the rheostat with the cause of the equal resistance value of the each sending unit circuit resulting in equal heating of the gauge. The bimetallic strip cause of the gauge read 1/2. Fuel levels above and below the half that will cover the tank. The unit divided the voltage of the gauge by metallic strip that will cover the proportion of the correct gauge reading. Is an example of 1/4 full fuel tank at the level of the tank would divide the voltage, and then 75% of the current will flow through the right side of the strip. The 25% would flow through the left side of the strip. This would produce a 1/4 gauge reading. Alright, your magnetic field gauge. The basic instrument in the panel gauge consists of the point with the mount of the armature. Depending on the gauge design, the armature may contain either one or two poles. The gauge is motivated with a magnetic field that is created by the two separate magnetic coils that are contained in this gauge. One of these coils is currently connected directly to the battery, producing a constant magnetic field. The other produces the variable field, whose strength is determined the rheostat type tank unit, while the operation is the same as described above the paragraph above. The thermostatic fuel gauge externally regulated. The coils usually are placed at 90 degrees apart. Alright, operation. When the tanks are empty, the tank unit creates a very high resistance. This causes variable magnetic coil to produce almost no magnetic field. Therefore, armature poles on the gauge point will be attracted to the constant magnetic coil. The pointer will point to the empty when the armature is in position. When the tank of the fuel of the tank unit will create no resistance. Therefore, the armature poles on the gauge pointer will be positioned midway between the coils. When the armature is in this position, the pointer will indicate the full reading. Variations of electrical system voltage will affect both magnetic coils equally. Therefore, it will not offset the differential created between them. Because of this, magnetic gauge is self-regulating and requires no voltage limiting device. The magnetic gauge is very sensitive to road shock. Sudden changes of the voltage, such as those caused by fuel sloshing in the tank, because of the armature instrumental panel gauge, will be fitted to dampen the device of the flywheel pressure gauges. Our pressure gauges are widely used in automotive applications to keep the track of things of the engine, oil pressure, fuel line pressure, air brake system pressure of the hydraulic system, and special purpose vehicles. Your electric gauge, the instrument panel with the thermostatic magnetic, the sending unit is used with each of the gauge varies as follows. Thermostatic, the sending unit with the gauge uses a flexible diaphragm moved as a grounded contact. Contact that makes with the grounded contact is attached with a heated bimetallic strip. Flexing the diaphragm, which is done with a pressure changes vary with the point of tension. The different position of the diaphragm produces gauge readings in the same manner. The differential position of float arm takes center in the paragraph above. The thermostatic fuel gauge self-regulating. Magnetic, the sending unit with the gauge also translate pressure within two flexing of the diaphragm. In this case, the magnetic gauge is sending unit over. However, the diaphragm operates as a rheostat. The flexing of the diaphragm is pressure center produces the same result as above. Those above with the float arm and the tank center that describe the paragraph above titled magnetic fuel gauge. The type of the center also can be used with the thermostatic gauge and volt limiting devices used. Or your indicator lamp. The oil pressure warning light is placed on the gauge of the main vehicle. The warning light, although not accurately indicated, valuable because of the high visibility event with low oil pressure conditions. Because of an engine, it can fail the damage permanently with less than a minute. Operator with the oil pressure warning light often uses the backup of the gauge to attract the instant attention of the malfunction. Warning light receives the battery power through the ignition switch. The circuit is ground completed through the engine center switch. The center switch is just a pressure-sensitive diaphragm that operates a set of contact points. Contact points that are calibrated to turn the warning light whenever the engine oil pressure drops below approximately 15 psi, depending on the equipment. Temperature gauges. The temperature gauge is a very important indicator of the automotive equipment. The most common use of the indicating the engine transmission differential, oil temperature, engine coolant temperatures. Electrical gauge, instrumental panel gauge, thermostatic magnetic sending unit used with each type of the gauge varies as follows. Thermostatic, the sending unit used with the gauges usually contains two bimetallic strips, each with the contact point. One bimetallic strip is heated electrically. The other bends to increase the tension of the contact point. At different points of the metallic strip will create readings in the same manner with the different floating arm positioning of the tank center. Magnetic, sending unit which for the gauge contained with a device called the thermistor. Thermistor is an electronic device whose resistance increases proportional as the temperature increases. The type of the sending unit also can be used as a thermostatic gauge if the volt of the limiting device is used. Alright, indicator light. The temperature of the warning light is used with the main vehicle in place with the gauge. Indicator light, although not as detailed as the gauge, valuable because of the high visibility event of the overheating condition. Because the engine can be also damaged permanently with it destroyed operating in short periods, while overheated warning lights often are used as backup for temperature gauge to attract instant attention to the malfunction. Alright, the warning lights. The warning light receives the battery power with the ignition switch of the circuit ground complete with the engine center switch. The center switch contained with the set of the contact point that are operated with the bending of the bimetallic strip that is calibrated to turn on warning light approximately at 230 degrees Fahrenheit. Some models of the cold indicating light indicates that the engine has not reached operating temperature. Light used with the green color, whereas hot is indicated. Sending unit, the application is external and internal and center has an extra contact bimetallic strip. Simply complete the circuit with a cold light until the engine heat reaches approximately 150 degrees. Then the strip will open and the cold light will circuit cold light circuit. As long as the temperature of the engine is normal, a metallic strip will remain between the contacts of the cold and hot indicator lights. Speedometers and tachometers. Alright, speedometers and tachometers are usually virtually all the type of the automotive equipment. Speedometers are either to indicate the vehicle speed in miles per hour, kilometers per hour, and most of they call it the speed meter that contain the odometer. The device with a permanent record with the mileage of the vehicle has been used. Some speedometers also contain a trip odometer that can be reset to zero at any time of the individual trips that can be measured. Odometer is calibrated to measure the distance in miles and kilometers. Depending on the application, the tachometer is a device that uses to measure the engine speed. The RPM of the tachometer may also contain a device known as an engine hour rate, which is usually installed with equipment that has no odometer and keep the record of the engine use. Electric speedometer tachometer use the mechanically driven permanent magnetic generator usually supply the power from an electric motor that has been used with the rope input shaft of the mechanical speedometer tachometer. The voltage of the generator will increase proportional with the speed. The motor speed will likewise increase proportional with the voltage. Enable the gauge to indicate. Single generator with a speedometer will usually driven with the transmission output shaft through the gears. Single generator with a tachometer usually driven with a distributor through the power takeoff of the gasoline engines. When tachometer is used with the diesel engine, the speed power takeoff division is made usually on the camshaft drive. Electronic speedometer tachometers are self-contained units with electronic signal with the engine transmission indicator with the formulated reading differ with electrical units with the generated signal with the driving force gauge unit with the transistorized and will supply the information for either with the magnetic analog dial or limiting a lighted diode. Digital gauge to display the gauge unit derives the input signal with the following units. An electronic tachometer can be obtained with the pulse signal with ignition distributor, the switch, and the coil on and off. The most popular signal source for the tachometer that is used in a gasoline engine, the pulse speed at the point of which the change is proportional with the engine speed. The tachometers are used with a diesel engine with it causes alternating current generated at the short terminal AC generated with a signal to the frequency of the alternating current will change proportional with the engine speed. Electronic speedometer derived the electronic pickup with the coil that has field interrupted rotating pole piece signal unit operation. The same operation of the electric pickup coil. The pickup coil is located strategically in the transmission case to interact with the reactor teeth located on the input shaft. Your horns. Principal operation. Most common type of the horn is the vibrator horn. The general principal operation is the same as the vibrating coil. The vibrating diaphragm is operated with the coil, also operated with the contact of the braking in the circuit. Magnetism of the coil pales of the diaphragm toward the contacts are closed. The contacts are then pulled open, the coil reducing the magnetism, allowing the diaphragm to return to the normal position. When the contacts are closed, this new surge of the current induces the magnetism in the coil to serve the second movement of the diaphragm. The cycle is repeated rapidly. Vibration dampened within the air column produced the note of the horn, tone and volume adjustment made with the loosening of the adjusting lock nut, turning of the adjusting nut. This is very sensitive adjustment control of the current consumed by the horns. Increase the current, increase the volume. However, the too much current will be a horn disputer and may lack the diaphragm. Your dual horns. Dual horn, one horn will low pitch blend with another horn with a high pitch. These horns are, although operated electrically, produce a sound closely resembling the air horn. Sound frequency low pitch horn is controlled with a long air column. High pitch horn sound frequency is controlled with a short air column. The air column is formed by a projector with spring spiral patch cast in the base of the horn. Control of the current drawn with the horn is very high. Therefore, it's usually operated by a relay with the control switch. The control switch usually is mounted on the steering wheel. The control with the button of the horn ring. The horn receives the electronic current through the ignition switch relay contact point. The relay contact points normally are open, keeping the horn from operating. The relay contact points are closed whenever the magnetic coil is energized. Magnetic coil receives the positive battery current from the ignition switch. The horn would switch completely to the circuit to the ground. Air horns. Air horns is a trumpet-like device that operates with the compressed air. Air horns usually are used with the vehicles equipped with an air brake because they can operate with the vehicle's compressed air system. Air horns may also have their own compressed air system. Air horn is controlled by air valve. Backup alarms. Large vehicles sometimes use an air and electronic horn at the rear of the actuated when the transmission shift is to reverse. The purpose of this is warn pedestrians that the vehicle is backing up. Windshield wipers. Electrical windshield wipers are the most popular type of the modern automotive equipment. The electrical windshield wipers operate at a constant, easily controlled speed, making them much more desirable than vacuum counterparts. One of the drawbacks of using electrical windshield wiper in the early automotive equipment due to the heavy electrical current, the requirements for the motor placed on the vehicle of a 6-volt electrical system. This problem was solved with the 12-volt electrical system becomes stranded. The electrical wiper motor with the worm gear drive the shaft that is connected to the crank. Circle motion of the crank is transformed reciprocating motion by the wiper transmission to operate the wiper arms. The G for the control switch, G for the control of the windshield wiper separate mechanical operated park switch is also incorporated to the motor. This purpose switch provided power to the wiper motor long enough to return the wiper arms and blades to the retracted position wherever they are switched off by the operator. And then he shows the practice exercise for lesson 4, learning event 3. And this completes your U.S. Army Light Wheel Vehicle Mechanic MOS 63B Skill Level 3 Wheel Vehicle Electrical System Parts Part 2. Subcourse number is OD 1003.